Hi everybody, welcome back. This week we're going to cover Module 5, which is linear functions and linear regressions. Here you will have the PowerPoint presentation with all the animations about the linear function and linear regression. Then remember you're going to have the support materials, some text and videos about the linear function and linear regression. We also have a question forum. If you have any question, any doubt, any concern about the topic we're going to work this week, then you have your check your understanding for this module. So here you will find some exercises you can solve, up to you. If you have any doubt, you will have here the solutions and also some videos explaining how to solve those exercises. And by the end of the week, you have to complete the following assignments: the discussion question number 3 and the quiz number 3. So about linear functions, is mandatory for you to refresh to know what the average rate of change is, because remember, the average rate of change of a function over a closed interval, in this case a and b, is the difference between two outputs divided by the difference between two inputs. That's the average rate of change. For example, in this table of values, if I want to find the average rate of change between 1990 and 1991, between 1991 and 1992, and so on, okay, we have to use our formula in order to find the average rate of change. So between those 2 points here, between the closed interval 0 and 1, which is 1990 and 1991, my average rate of change would be -8. The next one is going to be -7.7. The next one is going to be -3.8. And the next one is going to be -10.2. So from here we can see that the average rate of change is not constant. For now, let's see this next example. If I want to find the average rate of change between the input 4 and 2, between this interval here, these two intervals, remember this is 1 point and this is another point, the input, the output, the input, the output. So the average rate of change using the formula we have, for the first one 0.24, for the next one 0.24, and so on. And we can see here that the average rate of change is constant. So whenever we have two quantities that are related by a constant rate of change, the graph of this relationship is a line. So imagine you are in your car driving and you set the cruise control on. You will have the sensation of a constant speed. That would be constant rate of change. That means in the same amount of time, you're going to cover the same amount of distance. So this relationship is called a linear function. So the process to find out an output, in order to find the output of a given input, you can use this equation anytime if you have a constant rate of change and a known reference point. In a linear function, any point over the linear function you can use as a reference point, and the equation is always going to be the same. So the constant rate of change, remember, is the change in output divided the change in input. So that would be delta y divided by delta x, or x2 minus x1, sorry, y2 minus y1, or y minus y1, x minus x1. So you will have this equation here where you can find the final output with a constant rate of change and a reference point. In this case, as I said before, any point in the line, or any point, if you have a constant rate of change, is going to be a reference point. In some textbooks, you can find an equation like this one. where V in this case would be Y, which is the final output, is equal to the constant rate of change time changing input plus the reference output. Or you can find this equation here. And this equation would be the equation, the standard equation, I would say, for the linear function. So linear function, any function with a constant rate of change is called a linear function. Remember again, with a constant rate of change is a linear function. And the constant rate of change, we're going to call it the slope. And the term slope is also used to refer to the steepness of the graph of a linear function. Again, if the slope is positive, we're going to have an increasing function. If the slope is 0, we're going to have a horizontal line, which is also a linear function. And if the slope is negative, we're going to have a decreasing function. And we can find three ways of representing the linear function. Those are the slope-intercept, the point and slope, and the standard form. Each form has its own benefits. So for the slope-intercept form, we can find that y is equal to mx plus b, where m is the slope, and here we're going to use the vertical intercept, 0 and b. b is the y component of the vertical intercept. And we will call this b is commonly referred as an initial value. Another form is the point slope form. Maybe you won't have the slope, but you're going to have 2 points. So having 2 points, you can find the slope, and then you will use one reference point in order to find the final output. Then in this course, in this section, you will also have some exercises about the way to find the linear function, and also we're going to cover linear regression. So it's common when working with real-world data sets and the data will not be perfectly linear, we can use linear regression in order to find a linear function. And we can use that, we can find that using Desmos. And here in your slide, you will have a link in order to understand much better how to find the linear regression using Desmos. Of course, you're going to have some more examples. Okay, so this is what we're going to cover during this week. If you have any question, please don't hesitate to call me or email me. Thank you.